Hello everyone, welcome back to Computer Networks lectures. Now we're going to start talking about TCP protocol. And first of all, we are going to discuss about the segment structure and the characteristic of TCP. Okay, so first of all, TCP is a point-to-point, as we have seen before, and the multiplexing also the TCP socket. It requires four unique tuples, source and destination IP address, and source and destination port numbers to create the socket. So basically, only one sender and one receiver. Even though there is one receiver or one client having different processes, then it will be treated as a different sockets. All right, and then second one, it is a reliable and in-order byte streams. We already seen these terms before many times. As we will be discussing later, we'll discuss about the mechanism to provide reliable data transfers and also to provide in-order bytes delivery. And it also full duplex data, meaning that between, let's say, if we talk about the client and server, both client and server can send data in the same connection. Okay, and there is one term that we will use later in when we talk about the condition control called MSS, or maximum segment size. There's also a concept of cumulative acts. This acts actually an acknowledgement. It's short form of short form of acknowledgements. It is a message saying that the receiver already received the message sent by the sender. So there is then we will discuss about the concept of cumulative acts. And it also supports pipelining, meaning that the sender can send several segments almost at the same time before it receives the acknowledgements from the receivers. So, so for example, like it is also in the case of, for example, HTTP. There is also pipeline HTTP before even the sender receives the HTTP response or the client receives HTTP response, it can send several HTTP requests. And this is happening also in it also works in TCP, but the difference is that it can send several segments before receiving X. Now, the window size or the number of segments that can be sent or transmitted at that time is controlled by the connection control and the flow control. Okay, and then it is also connection oriented protocol, meaning that it requires handshaking between the client server or between the sender and receiver before they can actually exchange the message at the application layer. And finally, there is a flow control mechanism, as we will discuss later. This mechanism so that the sender does not overwhelm the receiver with a lot of data or a lot of segments. Okay, now we will see the TCP segment structures. The first two important informations are the same as UDP protocol. We have source and destination port numbers. And then the second one, we have sequence number. This is important to keep the bytes is in the correct order in the receiving side. Okay, and also there's acknowledgement number, and this is acknowledgement number, and this is the acknowledgement flag. Okay, so this flag, first of all, I will talk about this flag. When this flag equals 1, a flag equals 1, then it means that this segment is an ACK segment. Okay, or if there is another flag equals 1, then this segment is actually that kind of segment. Okay. Now this acknowledgement number is important to know whether the segment is already received by the receiver. This is important information for the sender, and both these are very important to make the reliable data transfer in TCP works. Sequence number and the acknowledgement numbers. Okay, and then we have the application data with different variable lines. Okay, there is a checksum. It's essentially the same as UDP checksum. There is TCP options with the variable length, and then we have length of TCP header. This is specific only for the header, unlike the length in the UDP header that comprises the whole segment. Okay, now there are three flags, R, S, and F. R for RST, SYN, and FIN. Okay, so these three flags are used for the connection management. Or RST or reset is to reset the connection. Like say, for example, if a client wants to establish a connection with the server, and if the server sends resets, it means that the server rejects the TCP connection request from the clients. And SYN is a flag that is used when establishing the TCP connection, both at the client side and at the server side. And FIN is used for closing the TCP connection, both in the client and at the server side. And there is receive window. This is information that is set by the receiver, and this is for at the flow control. So basically, it's the receiver is telling the sender that this is the maximum number of bytes that I can accept. Okay, so that it is not overwhelmed by the sender. And then okay, so there is congestion notifications. Actually, this will be discussed in more details later in the network assisted congestion information, because there's two options actually, and there is also information at the network layer. So but what we will discuss later, congestion control, it is something that is detected by the transport layer. But then in this part, this flag notifications, it is triggered by the network. Okay. Now there are other flags, but we are not going to say the details about that. Okay, so now we'll try to talk about the concept of TCP sequence numbers and X. Okay, so first, the sequence number is basically the byte stream number of the first byte in segments data. So for example, we have this bytes, okay, and then these are the segments, different segments with different colors. Okay, so the first byte of this segment, let's say this is the number. Let's say if we start from 0 or 1, let's say this is 1, then the sequence number of this segment is equals to 1. Okay, sequence number. And then let's say it has the length of 10 bytes. So from 1 to 10, and then this is the new segment. So the first sequence or first bytes of this segment will have sequence number 11. So and so on and so forth. Let's say if this also has the 10th bytes length, then the next byte will be the next segment will have sequence number 21. Okay, so this is the sequence number. Okay, the sequence number, as we have seen before, it is located at this field of the header, TCP header. Now we have the acknowledgement number. Okay, so besides the sequence number, we have the acknowledgement numbers. Okay, what is acknowledgement number? Acknowledgement number. So basically, acknowledgement number is the next sequence number that is expected from the other side. Okay, so we will see this. I mean, it is easier to understand this by example, but let me give you a simple explanation. So let's say this is the first segment sent by the sender. The sequence number is 1. Okay, and it knows that the length is 10. So when the receiver, okay, so this is the sender, receiver. Okay, the first segment is 10. It has the sequence number 1 and the length is 10. Okay, and then when the receiver sends it will give the information about the ACK number equals 11. Okay, and then it has this ACK flag equals to 1. Okay, so at the ACK segment that is being sent by the receiver, it will contain this information: ACK number equals 11 and ACK flag equals to 1. And it also has cumulative ACK, so we'll give this in example in later. Okay, so now the question is how the receiver handles out of order segments. The CP itself doesn't say about the mechanism, but it is up to the implementer. Okay, now we'll see the simple example of TCP sequence numbers and X numbers. We'll use simple telnet scenario. Let's say the host A and host B are using telnet session. The user type C, just one character C with 1 byte, right? Okay, so this sequence number is 42, and the X number is 79. Okay, so what it means, basically, when the user type C, the user A type C, it says that, okay, so this is the number 40, the sequence number 42. Okay, and then it is also telling the ACK number is 79, meaning that, okay, the next sequence number that is expected by host A from host B is 79. Okay. Okay, now when the host B send a reply, again, actually this is just echo again the C character to host A. The host B sends the sequence number 79 because it is the ACK number from host A is 79. This means that 79 is the expected, the next let's say the next sequence number expected by host A from host B. Okay, so from host B, since host B already received sequence number 42 from host A, so the next sequence number that is expected from host B from by host B from host A is 43. Okay. Okay. Now, when host A sends the next segment, the sequence number will be 43 because this is what is expected by host B. Okay, from host A, and then since host A already received sequence number 79 from host B, then in the next transmission, host A expects sequence number 80 from the host B. So the ACK number that is sent by host A to host B is 80. So we'll talk about this later in a more variety of retransmission scenarios. Okay, I think that's it for now. I'm going to skip this round trip time and timeout because it's not really relevant to our context. We'll see you again in the next video, talking about some events in the TCP receiver and the sender for the reliable data transfer. So see you again in the next video.